Let's take a look at the chain rule. If you recall, when we had functions that look like this and we wanted to take a derivative, the easiest thing to do would be to go ahead and simplify this algebraically. So in other words, multiply x plus 2 times itself, which is what that exponent means, to give you x squared plus 4x plus 4. Then when you take the derivative of x squared, it's 2x, of 4x, it's plus 4, and of 4 is 0. And so then you are done. But what happens when you get higher exponents? We do not want to multiply this out times itself 5 times. And so instead, we consider these as nested functions where you have an outer function and an inner function. The chain rule is the newest derivative rule that you're coming upon, that you don't have enough power with the previous rules to be able to take the derivative of a function that has that high power outside those parentheses. So instead, we think of it as this nested function where the u inside is some function of x. And then we take the derivative of the outer function, and then we chain rule out the derivative of the inner function. Let's try an example. We take that 5x plus 3 quantity squared and take the derivative by bringing the power of the outer function down, keep what's inside, subtract 1 from the exponent, and then we chain rule out the derivative of what's inside. So this gives us 10 times 5x plus 3, which is 50x plus 30. Now, if you went ahead and algebraically simplified this by multiplying it by itself, getting a quadratic, and then taking the derivative, you would get the exact same thing. And so the argument is that when you have a quadratic, the easier thing to do is to go ahead and expand and then use the power rule to find that derivative. But using the chain rule gives you the exact same thing. And so that's just a double check to show yourself that it does work. We use the chain rule when we have higher powers, or we have an outer function that we can't simplify algebraically, so we end up with this nested function that we can't do any other way. Here's 1 to the 4th power. And so when we take this guy's derivative, f prime of x, we bring this exponent down to the front to give you 4. Keep what's inside. Take 1 away from the exponent, and then chain rule out the derivative of what's inside. If it's just a number, that chain piece, then calculus etiquette says to go ahead and multiply that by that original leading coefficient. And so this is our final derivative then. When we have something that looks like this, you've got a nested function where the x cubed minus 3x plus 1 is all the inner function, and that outer function is that square root. Now, we want to put this in exponential notation because then we can use the power rule to be able to take the derivative. Now this is to the 1/2 because what's inside is raised to the 1st power, and this is a square root, and so we use a 2. When we take this derivative then, f prime of x, 5 stays, the 1/2 of the exponent comes down, we're going to rewrite what's inside, subtract 1 from the exponent, and then we're going to chain rule out the derivative of what's inside. So immediately, though, you rewrite exactly what's here. That's the most common error, is to take a derivative inside here, and we don't do that. We don't take the derivative until we chain rule, and you get 3x squared minus 3. And so again, you bring the exponent down. It gets multiplied by this. Keep what's inside. So the outer function's derivative is bring the 1/2 down, keep what you have, subtract 1 from the exponent. That's the power rule. But the expanded power rule, or what we call the chain rule, is when you do that, what's inside has its own derivative, so it then has to chain rule out its own derivative. when you have something that looks like this, sure, you could use the quotient rule, but we don't need to. Let's go ahead and rewrite that with a negative exponent, 3x squared minus 2 raised to the negative 5 by exponent rules. And then we're going to have to use the chain rule because we have a nested function. Bring the negative 5 down, keep what's inside, subtract 1 from the exponent, chain rule out the derivative. And that's the language you use every time. Now on the last one and this one, I didn't simplify. You can leave it like this, or if you're asked, if you're doing some online homework system, you're going to have to go ahead and multiply this over. Really, you can rewrite this entire thing if you so choose. This is really negative 30x, the negative 5 times this. And then that raised to the negative 6 can be rewritten in the denominator to the 6th power. So fully simplified, it looks like this. This tells us this function is 0 when x is 0. We could also find when this denominator is 0 to find out where it's undefined. Both of those are interesting thoughts. The reality is, though, we typically, when we get beyond the chain rule, is that we will take the derivative and evaluate it at a specific x value. So we're just substituting in and then simplifying. So that's typically, we leave it like this. So that's it. Hope you're having a great day.